Objective is to showcase the work that our postdocs are doing. My name is John Motter, and I'm a member of the Earth Institute faculty and the faculty at CEPA and the faculty at Earth and Environmental Sciences. And I pretend to direct this program, but really Natalie does, or she does all the heavy lifting anyway. We're making our selections for the next intake. What you'll see here is, in many instances, works in progress. So these are not sort of final project reports. So if things look like they're a little bit in process, it's because they are in process. In the spring, we'll have another one of these. The way we're going to run this is the order will be exactly what you see here, except that the last listed person is actually going to speak first. So, so Hannah Nissen will speak first. Hopefully, the next two on the program will be here. We'll take a little break after 3 people have presented, take some questions, maybe you can get some coffee, and then we'll go through the next 4 and then have another set of questions. This is one of the most beautiful rooms in the whole of the university. Because of that, it's highly sought after. So there's an event in here very soon after this one. So we have to stick to our time and get out at about 4:30. Okay, so speakers need to stick to their time and questioners need to be brief, if possible. So I think that's enough from me. So Hannah, would you?
Hi everybody, my name is Hannah Nissen. I work for the International Research Institute for Climate and Society, one of the Earth Institute centres. I also work with the Red Cross Red Crescent Climate Centre, which is a really great connection that helps me to kind of very much try to transfer from research to operations and try and guide my research very much by how it can actually be used on the ground in a humanitarian context. I'm going to start just with this statement. Heat is one of the most dangerous climate hazards for human health, but most people are unaware of how serious it can be. We've had a lot of major media grabbing headlined heat waves in mid and high latitude developed countries. It's becoming more and more accepted that this is a real problem in Russia, Europe, North America. But when you go down to the tropics, that's, in my experience, really not the case. You go to I've been working in the Caribbean and all across South Asia, and I talk to people about heat waves. And they say, yeah, it's hot, it's the Caribbean. It's always been hot. It's always been hot ever since my childhood. I'm used to it, it's fine. But when we actually look at the data, we realize that there's clearly a very large discrepancy between people's perception of heat risk and their own exposure to heat stress and what the data actually bears out. There was a heat wave in Ahmedabad, a city in India, in 2010. And this was big enough to actually grab the attention of the city authorities. And this study that followed on from it, it was done by the Indian Institute of Public Health and by NRDC in the US, they found that actually there were nearly 4,500 excess deaths during this 1-week period in Ahmedabad, excess being greater than normal climatology for that time of year. So clearly it is an issue in India, and we assume across South Asia. And this prompted the setting up of South Asia's first heat early warning system. So this is a system where people try to take action to prepare for an event based on a forecast, so in advance of that actual event happening, to try and reduce the ultimate outcome. And there is very much a sense of momentum around this issue of heat risk in South Asia. So the World Meteorological Organization, the World Health Organization are very motivated to support early warning system development in different cities across South Asia. And my work for the last year has been about trying to establish and build up the evidence base that would support the setting up of such a system in Bangladesh. Because there really is an extraordinarily little understanding of what causes heat waves in Bangladesh, who they affect, how we can predict them, and how we could cope with it better. So what is a heat early warning system? Well, it's part of a much wider heat action plan. It's by no means every aspect of an adaptation strategy to extreme heat, but it's part of one. And it's the part that's focused on taking action based on weather or climate forecasts. So this could be on seasonal timescales, it could be on sub-seasonal timescales. Most commonly, it's weather, so a few days out to a week. Going back to Bangladesh, luckily I'm not starting from scratch, so I've teamed up with a postdoc at the Mailman School here at Columbia, whose name is Katrin Burkhardt. She did her PhD on heat mortality relationships in Bangladesh, and she showed that there is indeed a strong connection between death rates and temperature in Bangladesh. You can see, well, so the bars, which may not have come out so well, show the distribution of mean daily temperature. And the curve is the relative risk of mortality at different temperatures. So obviously the first thing is that there's clearly a cold effect on mortality, but we're focusing on the heat mortality effect. And you can see that the relative risk of mortality rises sharply above about 35 degrees. So we know that there is a problem in Bangladesh, but that's not enough when we're talking about early warning systems. In order to trigger some kind of a warning and a set of actions, we have to say, yes, it's a heat wave, no, it's not a heat wave. It's not enough to say we know that heat is dangerous. So we need a definition. And when it comes to thinking of a definition, there's this tension between fidelity, so accurately describing the actual heat stress a person experiences, and that depends on any number of factors that may be meteorological, but they're also social. They're also clothing and level of physical activity and condition of their general health. So accurately describing those so that whatever our definition is actually is relevant for the health sector, and coming up with something that we can actually forecast, because if we can't forecast it, then we haven't got anywhere in terms of an early warning system. So how do you do that? Well, you do it by teaming up with an epidemiologist. So we came up with a list of 6 potential different indicators for heat waves. And these tested out well-understood theories about what causes death from heat waves from different places around the world. So daytime versus nighttime conditions, humid versus dry, different durations. And what we found was that the best definition for Bangladesh is when both nighttime and daytime temperatures stay high for 3 consecutive days. And what we found is that on those days, the mortality rate is 22% higher than on other days, when after Katrina controlled for various different long and short-term confounding effects. And all of this, the heat waves happen between April and June, and that is the pre-monsoon season in Bangladesh. So the main monsoon comes along sometime around mid to late June. But in this pre-monsoon season, the climate is characterized by very hot temperatures, but also by intense and very intermittent rainfall, thunderstorms and heavy rain. And the circulation is a balance between this northwesterly flow, dry northwesterly flow that's coming in from India, and moist air that's coming up from the Bay of Bengal from the south. And it's that moist air from the south that drives the rainfall that happens during this season. And what I found is that by compositing the atmospheric circulation, looking at reanalysis data, I composited the circulation on heat wave days. So this is the average wind at low levels and mid levels of the atmosphere on heat wave days. And what you can see is that there's basically on these days, that dry air from India is winning out. Potential forecasting bonus. And it bears out in the rainfall, of course, because that southerly wind that we're not seeing is what actually causes the rain. This is the accumulated rainfall anomaly from 0 days, so on the day of a heat wave, all the way back to 30 days, and you can see it's below normal for that whole period of time. The thing about rainfall is that it's very variable, so if you're trying to monitor it and try and detect changes or signals, it becomes quite hard, particularly over short periods of time. But soil moisture acts as a kind of integrator for all of that. So it has much lower variance, so it's much easier to detect changes. And we see it also in the soil moisture. So this shows the average, the total soil moisture over the country, and the deviation of that from what is normal for that time of year. And what you can see, the bottom is the lead time, so 90 days before a heat wave, all the way up to the day of a heat wave. And you can see that before a heat wave, it really just drops off a cliff. So it should be quite clear, if you can monitor this, that you're at a heightened risk of heat wave occurrence. But actually, it seems to potentially go back quite a long way. So, to summarize those last couple of slides, it seems that heat waves are basically associated with an absence of a normal climatological rainfall pattern at that time of year, and that's brought about by a circulation pattern that we seem to see about 10 days before an event. Okay, so that's great, but what does it mean about actually being able to predict something? Can we say, we know that heat waves are associated with low soil moisture, but can we say that low soil moisture is associated with heat waves? Is there any predictability there? And this shows that the odds of a heat wave are about 3.5 times higher following a period of dry soil moisture that lasts about 10 days. If it goes out to 30 days, the predictive power gets less, but it's still about 3 times more likely to have a heat wave 30 days in advance when there's dry soil moisture. So this is quite exciting in terms of subseasonal predictive possibilities, because that's really the timescale over which humanitarian organizations like the Red Cross are really excited about being able to take action, because there's a lot of things you can do 2 weeks before an event, but far fewer things you could do, say, 3 days before a hazard hits. We can also see it across the years. So this is based now, if you look at that soil moisture in the top right, you can see that that anomaly stays negative for quite a long time during the season. And we can see it when we look interannually. So the years which have a higher amount of rainfall during this pre-monsoon season and have wetter soil moisture have fewer heat waves. And the years which have drier pre-monsoon season have more heat waves. So this would be great if we had seasonal predictive capacity for rainfall at this time of year. At the moment, we don't have that, and it hasn't really been explored that much, but it would be a great area to look next. So, in summary, they've got maximum temperature every day. They don't have all different complicated versions of wind speed. They don't have humidity of very high quality. So it's good to keep it simple. And we know that these days are actually related to mortality. So that's a mandate for public health intervention. And that's really important to people working in the public health sector. They won't do anything unless they can see this is going to impact human livelihoods. And it appears that it might be predictable from timescales of days up to seasons. Clearly, the next step on that is to actually try and translate that into some kind of forecast product that will make it useful. But for now, I think the greatest potential is in monitoring soil moisture. So we don't necessarily have predictability for rainfall around that time of year at the moment, but we can monitor soil moisture using satellite products and other things. And so if we do that, we might be able to get some increased lead time on a heat wave occurrence. It's very much ongoing. I've mentioned turning this predictability study into forecasts, but there's a massive gap here, which is in vulnerability. There's a huge social science realm here that is really very underexplored in Bangladesh and across South Asia. We don't know who is vulnerable, we don't know where they are, we don't know how to intervene. This is also all about average conditions across Bangladesh, and that's because of a lack of data, but clearly we need to understand a bit more about the spatial variations of heat in the country, when a heat wave hits, where's it going to hit. But this other side of work that I'm involved in is around the operationalization of all of this work. So trying to work together with the Bangladesh Met Department, with the health sector, with policy people to try and put in place all of those other elements that would constitute a heat action plan. I mean, the forecast is only one part of it, and a lot of things have to come together before the actual forecast will turn into action. So that's kind of where I'm focusing a little bit more for the next year of the fellowship. So that's it.